So the questions related to rate, redox, and reversible reactions, more examples as we have already discussed few of them in the last session. The draw Maxwell-Boltzmann diagram on the axis below and label the activation energy for a reaction and the vertical axis. So on x-axis we have kinetic energy. So what will be the label on the y-axis? So you can mention proportion of the molecule or fraction of the molecule or number of the particle with given energy. With the important thing is you should mention the number of particle or fraction of the particle or proportion of the particle. With a given energy is optional. So if I write here fraction of the particles, because we don't take normally the full particle, it's just part of the particle. So that's why we can say fraction or particles. Or even number of the particle is also acceptable. So when you sketch a graph here, the Maxwell-Boltzmann distribution graph, so particles will have when we increase the temperature, the kinetic energy, like when we check the distribution of energy, most of the particles will have probable energy. But keep in mind, this graph won't intersect the x-axis. If you write like this, then it is wrong, because it will continue. So don't touch on the x-axis. This is a very common mistake student used to make. So you should avoid this mistake. Don't touch, because otherwise what does it mean? It means there is we limit the energy, but there is no limit. Like particle can have any energy, that's why we cannot limit their energy. So we simply continue the graph, but we don't intersect on the x-axis. And we can label the activation energy EA. So with a dotted line you can label activation. Use your diagram, explain how the presence of the catalyst such as chromium 3 oxide affects the chemical reaction. So how the chromium 3 oxide affect the chemical reaction? So it lowered the activation energy. As a result, when it lowered the activation energy, there will be greater proportion of the particle with activation energy. That's why the rate of the reaction will increase. So this same explanation you have to write in the space given. Suggest how solid catalysts work. Basically how a catalyst work, a solid catalyst or heterogeneous catalyst work. So what they do, like example, if you check manufacture of ammonia by a Haber process. So what are the reactant? We have nitrogen and hydrogen. So how these heterogeneous catalysts are working? So this is a catalyst example, iron is there, example for manufacture of ammonia. What are the reactant? The reactant are nitrogen and hydrogen. So nitrogen and hydrogen are reacting. As a result, they're forming ammonia. N2 plus 3H2 gives 2NH3. So what happened in nitrogen molecule? There's a triple bond in nitrogen molecule and there's a single bond in hydrogen molecule. So first, these heterogeneous catalysts, what they do, they trap the reactant molecules at the surface. That is one thing. And when they trap the reactant molecules at the surface, they weaken the bond in the reactant. So first they trap the particles on their surface, and as a result, when they trap the particle on the surface, they weaken the bond within the reactant molecule, which can easily break down. And as a result, what happens? The activation energy will be lower, like this reaction can proceed at a lower temperature. So first thing you can mention, the catalyst, the heterogeneous catalyst. They will trap or absorb reactant molecules on the surface. Then after they trap the reactant molecules at the surface, then what will happen? They weaken the bond. So which bonds? Here the reactant bond, like example nitrogen nitrogen triple bond and hydrogen hydrogen single bond, that is weakened as it is trapped or attracted towards the iron. So they weaken the bond of the reactant, and as a result, when they weaken the bond, the activation energy will be Activation energy decrease. As activation energy decrease, the same reaction can proceed at a lower temperature. Is it clear, this part? So this is always the case when they ask. This is always the case whenever they ask how the catalyst work, and they mean to how heterogeneous, because homogeneous catalysts, they work in a different manner that you will study in A2. Chromium 3 oxide catalyzed uh, chromium 3 oxide catalyst can be used for remarkable demonstrate called dichromate volcano. So one experiment of operators use silica gel granules are there, ammonium dichromate. We heat it. The substance used is ammonium dichromate. Give a formula of ammonium dichromate. So we have to work out the formula for ammonium dichromate. So ammonium ion is NH4 and dichromate is Cr2O7. So ammonium is NH4 with a valency of +1, and dichromate is Cr2O7. Dichromate 6, so chromium. So the valency here, because each oxygen is -2, so 7 oxygen -14, and each chromium is +6, so -14 plus 12, so that will be equal to -2. So we cross multiply. When we cross multiply, it will turn out to be NH4 in a bracket 2, then Cr2O7. The thermal decomposition reaction is a redox reaction involving the oxidation of nitrogen atom. However, it does not require oxygen gas. Suggests how the procedure could be modified to confirm that oxygen is not necessary for this oxidation. Like in this reaction, how we can make sure that we don't need oxygen. So what we can do, the same reaction as you can see in the flask, we have ammonium dichromate. In the question they're saying we don't need oxygen for this reaction, it can proceed without oxygen. So what we should do, we should make the environment inert. What we can have argon gas inside the flask, so replace the air by argon or any inert gas, so that if the reaction proceed, it means oxygen is not needed for a reaction. That is just a confirmation. The next part, from your knowledge of dichromate compound, suggests the color which we observe, the because chromium 6, you have to learn these colors. We have, if it is dichromate, it is orange. If it is chromate ion, it will be yellow. Like these are the colors which you should learn. If we have Cr2O7, uh, it means it will be orange in color. If we have CrO4, it means it will be yellow chromate ion. And when we have chromium ion, it will be green. As I mentioned, the reaction occur, it is a redox reaction in which the nitrogen atom, oxidation of nitrogen, so chromium, it will be reduction. So what is the common oxidation state which the chromium reduced to? So chromium +6 in a dichromate, as the oxidation number of a chromium in dichromate is +6. So I'm just writing oxidation number changes from +6 to +3. We don't write oxidation number, we just have to mention observed. So that because this chromium 6, in even in dichromate or chromate, chromium oxidation number is +6. But in dichromate, it is orange in color. So this will be orange in color and it changes to chromium. So it will turn into green. So orange color turn into green color. the oxidation number of a sulfur in thiosulfate. So how we can work out the oxidation number of sulfur in thiosulfate? So it is S2O3. The whole molecule is a charge -2. Each oxygen is -1, 3 oxygen will be -6. Each sulfur is X, 2 sulfur will be 2X. So 2X minus 6 is -2. Now mathematical equation. So 2X minus 6 is -2. This is minus, other side it will be added. So it will be -2 plus 6 is equals to 2X. -2 plus 6 is +4. So 2X is +4, or X is equals to +4 divided by 2, or X is equals to +2. So A will be the right answer. Then chlorine is used to prevent the growth of a bacteria in a swimming pool water. It reacts as shown. Chlorine react with water molecule from HClO, HClO and HCl. Give an appropriate oxidation number. Explain why this reaction is having both oxidation and reduction. So chlorine here is 0, chlorine here is -1, and here each oxygen is -1, -2, hydrogen +1, so chlorine is +1 as well, because overall molecule is neutral. So when we check why this, first we have to mention the oxidation number. So we'll mention for oxidation number of a chlorine, oxidation number of a chlorine is 0 here. In HCl it is -1, in HClO it is +1. So the same element, reduction and oxidation happen. That is why this reaction is disproportionation reaction. Like the same element, whenever a chemical reaction, same element is oxidized or reduced. So here chlorine is oxidized as well, and chlorine is reduced. The next part, state and explain the effect on the position if the concentration of hydrochloric acid, if concentrated hydrochloric is add sample. So if we add concentrated hydrochloric acid, like we will have more product. As a result, the equilibrium will shift towards the left hand side. So our HCl will mix with HClO and shift the equilibrium towards the left hand side. It's of 3 marks. What is the distribution of the mark? How you will get all the 3 marks? 1 mark when you mention that equilibrium is shifted towards the left hand side. This part is of 2 marks. So equilibrium shifted toward the left hand side, and the second mark is for mentioning that HCl will react with HClO to restore the equilibrium. That's why more chlorine and water are formed. Then complete the ionic half equation for reaction of ClO with acidified potassium iodide, balance them and adding electron where required. So first, what is the rule? To balance oxygen, we add water. So we have 1 oxygen, we added 1 water. To balance hydrogen, we add proton. So we have 2 hydrogens, so we should add 2 proton. To balance the charge, we add electron. What is the net charge here? -1. This water is neutral. What is the net charge? This is -1 and +2, so net charge is +1. So we want the -1 net charge. So what we should do? We should add electron towards the left hand side. And how many electrons we should add? So we should add 2 electrons. So there will be 2 electrons on the left hand side. For this bottom equation, iodide, because there is no oxygen involved, so we don't have to add water. There is no hydrogen involved, so we don't have to add proton. And to balance first the iodine, so this is 2, so iodine is balanced. Then charge must be balanced. Here the charge is -2, so we need here neutral, so we need -2, so we should add 2 electrons on the right hand side. So 2 electrons on the left and 2 electrons. Then we have to use your equation to write overall ionic equation in acidic condition. So as you can see, this balancing is already in acidic. Now to make the balance equation, we make the number of electrons same and add. You can clearly see that the number of electrons are already same, so we don't have to do anything like multiplication. We just directly write the equation. So we were having ClO plus 2 protons are there, plus 2 hydrogen, 2 iodide ion gives chloride ion, water molecule, and iodine. The iodine in the sample required a mean or average titer 24.2. The concentration is 0.5. Thiosulfate ion reacted with iodine shown. Calculate the number of moles of iodine. So how to get the number of the moles of iodine? We have the iodine of sample required. This is a volume which we need for thiosulfate, and this is a concentration. So first we'll get the moles of thiosulfate, moles of S2O3, that is concentration into volume. So concentration 0.05, volume is 24 divided by 1000. So we'll get 6.1 into 10 to the power minus 4. These are the moles. Sorry, 1.2. This will be, when we multiply this is 1.2 into 10 to the power minus 3. Then use the ratio here because we need thiosulfate. So the ratio, because we need the number of the moles of iodine. So the ratio between thiosulfate and iodine is 2:1. So thiosulfate S2O3 and iodine, the ratio is 2:1. So if we have 1.2 into 10 to the power minus 3, this will be X. Will cross multiply, we'll get the moles of iodine molecule. The total number of the moles of iodine, it will be 6.1 into 10 to the power minus 4 will be there. Then what is the number of moles of ClO ion in the sample of diluted bleach? So how we can work out the number of moles of ClO in the diluted bleach? We have to check the original and the relation, this equation which we already worked out. If you remember, in this equation we were having chloride ion, ClO ion was there, 2 hydrogen ions were there, 2 iodide ions were there, and it was forming Cl plus H2O plus I2. So now as we work out the moles of iodine, so we'll take a ratio of iodine to, because we know the moles of iodine molecule, so we'll take a ratio of iodine to ClO minus 1. And the ratio is 1:1. So if the ratio is 1:1, for the balance equation here in the question, what we need, number of moles of ClO ion in the sample of a diluted bleach. And we work out the number of moles of iodine in the solution. So iodine to ClO ratio, the previous equation was, yeah, 1:1 is the ratio. Yeah, that's right. So we don't have to solve much for this, as the ratio we worked out for ClO to iodine. So 1:1 is the ratio. Our previous answer for moles of iodine, it was 6 into 10 to the power minus 4. So we'll get the same number of moles of ClO ions in the bleach. Then what is the oxidation number of oxygen here? So the one which you don't know, you'll consider as X. So fluorine in OF2, fluorine is -1. So each fluorine is -1. So 2 fluorine will be -2 and the total is 0. So this will be X. So here X minus 2 is equals to 0, or X is equals to plus 2. Look, what is the concept here? if oxidation number we are getting +2, it does not mean oxygen loses 2 electron. Basically what happened when oxygen is sharing electron with fluorine, because fluorine is more electronegative, so what it appear that this electron of oxygen is almost shifted towards the fluorine, as it is more electronegative than oxygen. So that's why each fluorine will have -1, and oxygen is like appear as 2 electrons are being removed from oxygen. It is just an appearance, it's like a covalent bond. That's why the net charge on oxygen will be +2. That's why D is the right answer. Is it clear, this question? So these are some questions related to the topic rate, redox, and reversible. I'll share this sheet with you so that you can also solve questions related to the topic.